Okay, what we're going to do now is talk about how we apply this idea of percent composition to some other types of problems. So for example, let's say you had 35 grams of, I don't know, let's say just say aluminum oxide. What we would want to know is how many grams of aluminum could we extract from that 35 gram sample. So you've got a chunk of aluminum oxide. As you know, a certain percentage of this chunk is aluminum, and if we wanted to extract the aluminum from that sample, how many grams of just aluminum could we get from that 35 gram sample? So that's what we're going to do here. So we'll take a look at two problems and work our way through each of them. Okay, so let's say we had, and these are from your notes packet so you can follow along from there. So let's say we had 25 grams of potassium nitrate. So we have a sample of potassium nitrate, and as we said, that's made up of potassium, nitrogen, and oxygen. So we want to know how many grams of potassium we could get from that sample, or grams of nitrogen, or grams of oxygen. So the first step in this process is to figure out what's the percentage of potassium, what's the percentage of nitrogen, and what's the percentage of oxygen. Now we did this in the last vodcast, so I'll go through this pretty quickly, and if you're unsure about this, go back to Unit 5, Lesson 7, and watch the first part. So to figure out our percent potassium, what we did was we took the potassium part, which is 39, over the total in terms of molar mass. Whoops, that's supposed to be 101, times 100, and we got 38.6%. I am actually going to make my pen a little thinner here. Okay, for the nitrogen, we found that it was 14 over 101 times 100, and we got 13.9%. And then for the oxygen, we had 48 over 101 times 100, and that gave us 47.5%. Just remember that oxygen number here comes from the fact that we have 3 oxygens, not just one. Okay, so if we know our sample is 38.6% potassium, then 38.6% of that 25 grams has to be potassium. 13.9% of this sample will be nitrogen, and 47.5% of this sample will be oxygen. So to figure that out, we're going to use our basic math. So if 38.6% of 25, and remember when we say of in math, we mean times 25. Now you just want to remember when you write percentages in a math problem, we're going to move that decimal over 2 places to the left. So we're going to say 0.38, actually it's 0.386 times 25, and that is going to give us, sorry about that, that's going to give us 9.6 grams. So that tells us that 9.6 grams of this original sample is potassium. We can do the same thing with nitrogen. We'll take 0.139 times our original sample, which is 25, and that's going to give us 3.5 grams. And we can do the same thing with oxygen, 0.475 times our original sample, and that's going to give us 11.9 grams. That's supposed to say 11.9. Alright, so if you add up these 3 masses, then they should equal our original mass, which is 25 grams. So again, we have 25 grams of the original compound. By calculating our percent compositions, we can find out how many grams of each element in the compound we have. Alright, let's do one more example. So let's assume we have a 55 gram sample of aluminum sulfate. So what we're going to do first is figure out our percent aluminum. our percent sulfur, and our percent oxygen in this sample. And again, I'll go through this pretty quickly, so if you need a review, go back to unit lesson 7. So to figure out percent aluminum, we're going to take the aluminum, which would be 5. Here, let me rewrite that. Sorry, still trying to get a little bit used to this new system. So we have the aluminum part, which is 2 times 27, which is 54, over the total, which is 342. So that would be, the 342 comes from 2 times 27, 3 times 32, and 12 times 16. So we'll multiply by 100, and we get 15.8%. For the sulfur, we have 96 over 342 times 100, and that's going to give us 28.1%. And then for the oxygen, we have 12, 3 times 4, 12 times 16, which is 192 over 342 times 100, and that's going to give us 56.1%. So 15.8% of 55 will give us our grams of aluminum in a 55 gram sample. So again, we'll go 0.158 times 55, and that would give us 8.7 grams. We're going to take 0.281 times 55, and that's going to give us 15.5 grams. And then we're going to take 0.561 times 55, and that's going to give us 30.8 grams. And again, if we add up our 3 grams, they'll add up to be 55. So just once again, what we're trying to find is the grams of aluminum, the grams of sulfur, and the grams of oxygen in a 55 gram sample of aluminum sulfate. So what we're going to do in the lab is actually take these compounds and break them down and figure out how many grams of each element would be in the compound. So until then, take care.